Hi, and welcome to cen4930C. That's the Seminar in Advanced Software Development. And I want to explain a little bit about what we're going to be doing in the class this time and how the class is going to be structured. It may be a little different from what you've experienced in other classes, but then this is a seminar, and this is a chance for you to bring together a lot of material you've learned across many other courses in the BAS into one project. And I think it will be both challenging and fun. My name is Jerry Reed, and I'll be your professor. And let me just go ahead and get started, show you a brief PowerPoint. We'll talk our way through it, and I think it explains a lot about what we're going to do. Okay, the subtitle of this course in some way, since this course has different topics at different times. If you talk to folks in the past who've done the course, they might have done something different because the whole point of the seminar is that it changes to fit current activities and current interests. So the subtitle is Data Sources, Database Syncs, and Infographics. So I have essentially a three-part project that we're going to do together, and I think you're going to like it. So here's the overall flow of the class. Our theme is, as I said, sources, sinks, and visualizations. Now, sinks here doesn't mean like a kitchen sink. It means some place you put data, a repository. So a source is where data comes from. A sink is where you put the data, probably a database. And visualizations are what pull the data out and make them understandable, hopefully, to other people. I'm going to explain a lot more as we go along. This combines data engineering, which is a discipline related to data science. Essentially, it's the preparing of data to get ready for data science. It involves database design, and you should have had at least a course or two in database, and you get to use some of that knowledge here because the data we collect is going to go into a database and come out of a database. And some graphical coding, so making some kind of hopefully creative user interface or visualization to show the data that you're working with. That's all in one project. So it's 3 steps or 3 parts in one project. Now you can use whatever programming tools and languages you want to, if you wish. If you want to use Java, that's probably going to work fine for you. I think of this program as putting a lot of emphasis on Java. I don't know if that's absolutely true. I think it's likely that Python and JavaScript will come in handy for you. So if you need to learn those along the way, well, this will be a good opportunity. Or if you had the scripting languages class, you probably already have some familiarity with these languages. And of course, you're going to need to know some SQL, and at least for relational databases. Unlike the capstone class, now a lot of you are probably taking the capstone class at the same time that you're taking this class. This is not a group project, okay? It's not a team project. But by design, you will be collaborating with 1 or 2 students as we share data sources. So it's not like you're in a large team and you have discrete responsibilities. Everybody does the same thing, but as you'll see later on in a kind of plot twist, there's some swapping that enables you and causes you to interact with other students in the class. And I think actually that will be a positive thing for you. And then like the capstone class, the seminar draws on your classes and experience to date. And it's a good chance to practice again some of the skills that you picked up in the program along the way or that you picked up in life along the way. Let's talk about sources. This is the first part. A data source is data you obtain by, in the context of this class, you obtain data by either automated collection. So if you think about a Raspberry Pi or Arduino sensor collecting some data over time and putting it in a file and subsequently in a database, that's one possibility. That kind of has an embedded flavor if you want to go that way. You might acquire data by web page scraping using a tool like, say, Python's Beautiful Soup. Yeah, it's a crazy name, but essentially enables you to pull data off of, to mechanize the process of browsing as if you were a human using a program and pull data off of web pages that may not offer any other way to collect or save their data over time. And finally, web APIs. Often these are called RESTful APIs. I forget what that horrible acronym stands for. Usually that means it's some kind of JSON or XML interface over HTTP. And a lot of sites offer this as a way to get the data that you might want to use in your data source. So that's what a data source is in the context of this class. A data sink in this class it's a database. Now, it could be a relational database. Often it is, because we're all familiar with those and they work well. Or it could be a non-relational database. So for a relational database, you might choose to put data in a SQLite database or MySQL database. And for a non-relational database, you might use Mongo. That's the only one I'm familiar with, but I am fairly familiar with that. Again, if you had the scripting languages class, the Mongo database will sound familiar to you. It's a NoSQL database that enables you to put data in and pull data out using JavaScript as the query language rather than using SQL. The other deliverable in the sink is an appropriate documentation. By appropriate, I mean usable. Might be a data dictionary, but it probably also contains some other information that makes it so someone else can use your data to create a visualization. I think that's going to be a vital element. And finally, a sink is something that other students can use to create visualizations. So you create the data, you put the data in your database, either variety of database, and folks can pull it out to create a visualization using the documentation you provide. And there'll be a rubric for that to make sure you hit all the relevant portions to make your data usable. Visualizations is the final step, right? So you collected the data, you found the data and mined it in some way. You put it in a database in a sink. You cut it from the source, put it in the sink. Now it's time to visualize. And a visualization is just a program, like maybe a web page or another application that you use to create and explore the data that comes from a sink. Now, the very best visualizations are interactive. They're not just passive. They don't just show a chart. They actually allow the user to manipulate and adjust and interact with the data in some way. And we'll see how that works. So here's a sample scenario. So I'm going to walk through this as if there were only 2 students in the class. Obviously, there's a lot more than 2, but you can see how this works. Student 1 populates the SQL database via web scraping. So the student scrapes one or more web pages, probably over time, to get maybe some chronological data, and puts it in a database accessible through SQL. Student 2 does the same thing, gets data, but maybe student 2 actually gets it from some kind of Raspberry Pi or Arduino sensor and or an API, and this student he or she decides to put it in a Mongo database. Again, this is just an option, but puts it in a NoSQL database. Student 1 chooses to create a visualization of data from student 2's database. Student 2, in this case, chooses to create a visualization of data from student 1's database. Let's think about that. That's the plot twist. You don't get to visualize your own data source. You got to choose and visualize data from another student's data source. So everyone creates a data source, and everyone puts it in a sink, in their own sink, and everyone visualizes someone else's data. That's why documenting your data source and your sink is super important. I think a lot of stuff's going to come up doing it this way. When you create your own, and you may be tempted to skimp on the documentation because, I know what columns are which, I know what went in, I know where I got it from. When you have to prepare documentation that enables another person to use the data you collect, you'll have to be a lot more thorough, and you'll find a lot more problems with your initial take on it. And I think that's an important element of learning. So in this example, the swap is symmetrical, student 1 to student 2, student 2 to student 1. But obviously, in our class, it doesn't have to work that way. In fact, student 1 might use student 10's data, and student 10 might use student 7's data, and so on. You get to pick and choose which data source you use. Probably up to 2 people can do the same data source if necessary. So there'll be a lot of variety, and you can look through the data sources, you can look through their documentation, and you decide which one of these do I want to wrestle with for my visualization. I think that'll be fun. Obviously, there'll be interaction in the discussion forums over this as questions arise, and I thought I understood what this column does, but now I'm not sure. Or there's something really weird in this field, in this attribute in the Mongo database. Then you ask the person who created the data, the source, what goes on here? How do I fix this? What do we need to fix something? So I think there'll be some back and forth that way. That's what I meant by a collaboration. It's not a group project. It's not a team project, but it's a collaborative project. And of course, I'll provide links in the course coming up in the subsequent presentations to help you identify web scraping tools, visualization tools, and other things you may need to know to get this all to work. Now, we went through that very quickly. So here's a diagram that shows basically, and perhaps confusingly, what I'm talking about. So the places you might get data from, the sources, are maybe a sensor or sensors, a web page, or a web API. And wherever you get the data from, you put it in a sink, you put it in a database, either a Mongo database or a SQL database, as shown in the middle of this diagram. And then publish it, the documentation in your discussion, in a discussion forum, and then other students choose which data they want to visualize. Maybe student one chooses, as in my example, contrived example earlier, student one chooses student two's data, and student two chooses student one's data, or some other combination. So that's the basic idea. So that hopefully this picture helps to convey that. Of course, I'm open to questions on this. I know this is a brief overview and it may sound complicated, but this is essentially the same approach that I've used in a lot of other classes with somewhat simpler scenarios. If you were in one of my classes and you did the scenarios where, student A creates a scenario, student B implements it, student A provides feedback, that kind of thing, which I did in like every class, I think you know basically how this model works. So that's the plot twist. And it may sound intimidating at first. It is a fair amount of work because you got to collect data, put data in a database, and visualize it. But I think you'll find it fun and educational as we progress through the course. And maybe it'll make a good example for you to use as something you can put up and show in an interview or talk about on your GitHub. So that's the idea. Subsequent videos, I'll go into more detail about each step, but I hope this helps you get started and you should start thinking about what data you actually want to use. What data would you like to get from the web, or what data would you like to collect from a sensor, and be thinking about that for an initial post that's coming up soon. So thanks a lot, and I'll be talking to you in discussion forums and in videos again very soon.